Hey guys, this is Mrs. Lyons, and this video is going to show you what you need to know to be able to draw Lewis structures for ionic compounds. Okay, so last unit we talked about covalent compounds where electrons were shared, okay, between two nonmetals. And in class, we talked about how ionic compounds are made up of a metal and a nonmetal. And the bonding that takes place is a little bit different than what we're used to for covalent bonding. Okay, so just a recap, okay, from yesterday, the metal is always going to be the first element, and it's always going to give away its electrons to the nonmetal. Okay, this means that the metal is going to form a positive cation, or should I say positive cation, and a negative anion will be made from the metal. Okay, hopefully you took a minute when you were doing your bell work and wrote the charges of the ions above each column on your periodic table. So what you should be able to do eventually is look at your periodic table and be able to identify the charge that the ion would have. Okay, so we're going to practice drawing some of these Lewis structures. Okay, and they're very different. So what we're going to do first is we're going to do an example between potassium and sulfur. Okay, so the first step is to write down the Lewis dot structure for the element. So potassium is K. It's in group 1, so it has 1 valence electron. And then sulfur is S. It's in group 16, so it has 6 valence electrons. Okay, now what's going to happen in an ionic bond? Okay, remember in the covalent bonding we just connected the dots. We cannot do that anymore. Okay, that will be an incorrect answer. What happens in ionic bonds is the metal loses an electron. So this electron on the potassium moves over to the sulfur. Okay, now if you look at that, the potassium has gotten rid of its 1 valence electron. Sulfur needs 8 to obey the octet rule, and it only has 7. So I'm going to need another potassium, again with 1 electron, and that 1 electron is going to be given to the sulfur. Okay, now this is what we call the process. When we write this as a final answer, what you should see, you will have the non-metal, or the metal. So the metal is potassium. Since it lost an electron, it's going to have a +1 charge. Okay, we can put this in brackets. And if we put a little 2 back here, that shows that we have 1, 2 potassium to go with the sulfur. There we go. Okay. And then the sulfur, we're also going to write in brackets. The sulfur needs to include all 8 valence electrons around it. Okay. And then because sulfur gained 2 electrons, it's going to have a -2 charge. Okay. So we have to have 2 potassium. So sulfur can have 8 valence electrons. All right. So let's look at an example between aluminum and oxygen. Okay. Again, I'm going to start out by just drawing one of each element. So I've got aluminum. Aluminum is in group 13, so it has 3 valence electrons. Oxygen is in group 16, so it's going to have 6 valence electrons. Okay, so when we start to show this bonding process, aluminum is the metal, it's going to lose its electrons. So I can take one of these electrons over here, and I'm going to make it an X so you can kind of see that we've added it. All right, and then I can take a second electron over here. I'm going to make it another X. Okay, if you look, now this oxygen has 8 valence electrons. It's obeying the octet rule. The problem is we have an aluminum, we have an electron left on the aluminum. So I'm going to draw another oxygen with 6 valence electrons. Okay, so now what happens is the aluminum can give this last electron over to the oxygen. So now aluminum has gotten rid of all of its electrons, but we're still short one here for oxygen. So I'm going to draw another aluminum, and I know this seems tedious, but it will get easier. Okay, so now I can take one of the electrons from the second aluminum and put it on the oxygen. Now this oxygen has 8 valence electrons, but check it out, aluminum over here now has 2 left over. All right, so finally I'm going to add one more oxygen with 6 valence electrons, and now we can get all of these electrons from the aluminum transferred to the sulfur. Okay, so that's a really messy looking thing. So we definitely need to tidy it up a little bit. Okay, and you have to tidy it up. If you do this, you'll get about half of the points. What I need to see in the end is I need to see that we have aluminum with no valence electrons. Since it gave away 3, it's going to have a +3 charge. Now, the cool thing about these brackets is if I write the brackets, I can just count. I have 1, 2 aluminum, so I'm just going to put a little subscript down there too. And then for oxygen, oxygen has 8 valence electrons now. Okay. Each oxygen took 2 electrons. It gained 2. So each oxygen is going to have a -2 charge. And if you count, I have 1, 2, 3 oxygen. All right. So we need to have 2 aluminum and 3 oxygen to form a neutral compound. Okay, and we always have to form a neutral compound. Our charge overall over the whole compound has to be 0. So the positives have to cancel out the negatives. Okay, so now we're going to do something a little bit different. And this is called the crisscross method. Okay, and the crisscross method allows us a much easier way to figure out how many of each element there are. Okay, so if we look at calcium and oxygen, all right, so what I want you to do first is I want you to look at calcium on your periodic table. It's in group 2. So that means that calcium will form a +2 ion. Okay. Oxygen is in group 16. So it is going to form a -2 ion. Okay, so the crisscross rule, what the crisscross rule says is that we can take these charges and bring them down and they become the subscripts on our elements. So we would get a formula of Ca2O2. Now, anytime you are able, you have to simplify. So since these are both 2, I could simplify this to CaO. That would be my correct formula. So now let's draw out the bonding process. Okay, so I know I have 1 calcium, 1 oxygen. Okay, calcium has 2 valence electrons. Oxygen has 6. Okay, so now remember what's going to happen. Calcium is going to give its electrons away. So it can give one electron here and one electron here. Okay, so now we need our answer, our final answer. So our final answer is going to be calcium with no electrons around it and a +2 charge. And we can put that inside brackets. And then the oxygen has 8 valence electrons. And it gained 2 electrons, so a -2 charge. All right. Let's try this same thing with magnesium and nitrogen. Okay, so again, we're going to use the crisscross method to find the formula first. So magnesium's in group 2, so it's going to form a +2 ion. Nitrogen is in group 15, so it's going to form a -3 ion. Okay, again, the charges crisscross down and become the subscripts. So the formula for our compound is Mg3N2. Now, notice that I do not include my charges in my subscripts, okay? So your formula will never include charges. So now, this makes it way easier for us to figure out how many of each atom we need to draw. In this case, we need 3 magnesium and 2 nitrogen, okay? So, if we look at magnesium, it has 2 valence electrons. So I'm going to give each magnesium 2 valence electrons. Nitrogen is in group 15, so each nitrogen has 5 valence electrons. Okay, so if we show where the electrons go, okay, I can move 1 electron here. I can put 1 electron here. I can put 1 electron here. Okay, so it's kind of like in covalent bonding where you're looking for all of those solo electrons and figuring out where they need to go. The difference is in ionic bonding, the electrons are actually moving from one of the atoms to another atom. Okay, so now if I write this out, okay, what I've got is I've got magnesium. It gave away its electrons and it's forming a +2 cation. And I have 1, 2, 3 of them. And then nitrogen, notice the negative anion always ends up with 8 valence electrons. Since it gained 3, it's going to have a -3 charge. And we're going to have 2 nitrogens. Okay? Okay. So let's look at our next page. Okay. So before we get to some practice, we're going to talk about how we go about writing names for these simple binary compounds. Okay, we're going name to formula. All right, so binary compounds always have 2 elements, a metal and a nonmetal. Okay, it does not, simple binary compounds are not going to contain transition elements. Okay, the steps. Okay, first thing you're going to do is you're going to determine the charges. All right, and this is kind of what we were doing on those last 2 examples. It's actually really what we were doing. Once you find the charges, you're going to crisscross the charges. Okay, and then you're going to rewrite the formula so that the subscripts are included at the bottom. Do not write the charges again. Okay? If possible, simplify, like we did on that last example. Okay? So let's look at some examples of how this is done. Okay? So we have lithium sulfide. So if I look at my periodic table, lithium forms a +1 ion. It's in group 1. Sulfide is just sulfur. Okay, we changed the ending to IDE. So sulfide has a -2 charge. So if I crisscross the charges, the 1 is after the sulfur, the 2 is after the lithium. So my formula is going to be Li2S. All right, let's look at magnesium phosphide. Okay, magnesium's in group 2. The charge is +2. Phosphide just refers to phosphorus, so it has a -3 charge. All right, we're going to crisscross. Okay, so magnesium ends up, we need 3 magnesium and 2 phosphides or 2 phosphoruses. So what this crisscross method allows us to do is to figure out how many of each ion there are without drawing out the whole bonding process. Okay, one more, beryllium. Beryllium is in group 2, so it has a +2, forms a +2 ion. Oxide forms a -2. If we crisscross, we get Be2O2. So this is one of those cases where we have to simplify. All right, so both of these can be divided by 2. The 2's cancel out. We just end up with BeO. Okay, pretty straightforward. I think, let's see. Okay. I'm going to leave those practice for you. We're going to flip over to the next page, and we're going to talk about how we go from a formula to a name. Okay, so the first thing you do, you write the name of the metal. The metal always goes first. All right. Then you write the name of the nonmetal. And you change the ending to IDE. For example, bromine is going to be bromide. Sulfur is going to be sulfide. There's a couple of these. I'm gonna have you write these down because there's a couple of them that are a little tricky sounding. For example, phosphorus is phosphide. Oxygen is oxide. Nitrogen is nitride. These are some that just sound a little bit different because they've got more syllables. Okay, so here's some examples. Here we have Na2O. So Na is sodium. O is oxygen, so I'm going to change that to IDE, so OXIDE. So the name is sodium oxide. The numbers, we don't do anything with the numbers here. Okay. Mg3N2. Mg is magnesium. N is nitrogen, which we're going to call nitride. So magnesium nitride. All right, finally we have CaF2. Ca is calcium. F is fluorine, which we will change to be fluoride. All right, so calcium fluoride. Okay, so hopefully that was a quick run through of how to draw ionic compounds, how to write names from the formulas, and then formulas from the names. Okay, so what I would like for you to do is to finish the packet. I believe it's through page 9. Okay, so you're going to finish in the packet up to day 3. All right. I hope this video was helpful, and I will see you in class. Take care of yourselves.